Hello learners, welcome to this video lecture on green energy and zero energy in module 5 of energy engineering, presented by myself ranjithpk, assistant professor, Department of Mechanical Engineering, Global Academy of Technology. The topics covered in this video include green energy, its introduction, the fuel cells, the overview of the fuel cells, the classification of it, the various brief operating principles, then the concepts of nuclear, ocean, magnetohydrodynamic, MHD, thermoelectric and geothermal energy applications. We briefly look at their origin and their types and also their working principles. And then we understand the concepts of zero energy. So let's begin learning. Green energy comes from natural resources such as sunlight, wind, rain, tides, etc. These energy resources are also categorized as renewable, which means they are naturally replenished. This green energy utilizes energy sources that are readily available, and it can easily replace fossil fuels in all major areas of use, including the electricity, water, space heating, fuel for motor vehicles. And fuel cell is a combination of cells which is capable of generating an electric current by converting this chemical energy of a fuel directly into the electrical energy. It usually consists of a positive and a negative electrodes with an electrolyte in between them. What happens here is there is a fuel which is in a suitable form. It is supplied to the negative electrode, and then oxygen, which is usually from the air, picked to the positive electrode. When the cell begins to operate, the fuel gets oxidized and the chemical reaction provides the necessary energy that is converted to electricity. And the fuel cells differ from the conventional electric cells in the respect that the material which is used does not contain within the cell but are supplied from the outside. For example, when compared to a conventional lead acid battery that we use for in the clocks, the remote control toys, etc., the fuel consists from the inside, whereas for the fuel cells it is supplied outside. Most commonly used fuel cell is the hydrogen oxygen fuel cell. Now, how is this related to green energy? This is the fuel cell is a concept of the green energy, which is a renewable form. The fuels that is used are renewable in nature, and these fuel cells do not pollute the nature in any form, and hence is considered to be a category of green energy. So a basic working is there is hydrogen that is supplied as a fuel at the anode, and oxygen which is usually picked up from the air at the cathode, and there is a catalyst allowed at the membrane. What happens here is this two combine together to produce electric current, and the output of this is heat, and the air and water vapor is also the byproducts of it. So the combustion essentially or the mixing of the fuel essentially does not give the output in the form of any pollutants. So this fuel cell, the output is pollutant free. The classification is of these fuel cells is based on the type of electrolyte. It is classified as phosphoric acid fuel cell, alkaline fuel cell, then polymer electrolytic membrane fuel cell, or it is usually known by the name solid polymer fuel cell, or even sometimes proton exchange membrane fuel cell, molten carbonate fuel cell, and solid oxide fuel cell. This classification is, as the name suggests, is based on the type of electrolyte that is used for the functioning of the fuel cell. And the next classification is based on the types of fuel and the oxidant that is employed. In case of hydrogen oxygen fuel cell, the fuel is pure hydrogen and the oxidant is pure oxygen. And in case of hydrogen rich gas and air fuel cell, hydrogen rich gas is the fuel and air is the oxidant. Hydrazine, oxygen or hydrogen peroxide fuel cell. Hydrazine is the fuel and either oxygen or hydrogen peroxide is used as the oxidant. Similarly, ammonia air fuel cell, synthesis gas air fuel cell, hydrocarbon in the form of a gas and air, and hydrocarbon in the form of liquid and air. And based on the operating temperature, the fuel cell is classified as either low, medium, high and very high, depending on what is the temperatures that are achieved during the operation of these fuel cells. The next, based on the application, fuel cell which are used for space applications, vehicle propulsion, submarines, then defense applications, then commercial applications. Based on the chemical nature of the electrolyte that is employed, it is either acidic, alkaline or neutral. So the commercial application of this fuel cell has almost reached. There is a video here which depicts the commercial application, of course in a foreign country, not in our country, but nevertheless it is worth that the fuel cells are slowly progressing in terms of research, and it is being employed on a commercial scale.
Also der Befüllprozess selber ist genauso leicht wie beim Diesel, wird eine Befüllkupplung angeschlossen, verbunden mit dem Fahrzeug, dann wird an der Anlage der Prozess gestartet und nach 15 Minuten ist der Befüllprozess abgeschlossen.
Ja, sieht alles schöner aus. Es war vielleicht ein bisschen wackeliger als die älteren Modelle, aber vielleicht spielt sich das noch ein, sag ich mal. Vielleicht ist das alles noch, weil es so neu ist.
Heutzutage kann man ja gar nicht genug machen für die Umwelt, ne? Insoweit ist das schon sehr, sehr schön. Und ich würde das auch begrüßen, wenn da mehr Züge noch dieser Art unterwegs wären dann irgendwann mal. Das sind ja
So the key takeaway from this is that the passengers are happy. They are unable to find out the difference between a typically diesel operated train and the fuel cell operated train, and also still not widely used as a commercial application because of the cost. We now look at the few operating principles of various fuel cell. The first one is the phosphoric acid fuel cell. It basically consists of two electrodes which are porous in nature, and the material is conducting. It is basically conducting to collect the charge with concentrated phosphoric acid filled between them to work as the electrolyte. So the electrolyte here is the phosphoric acid, hence the name phosphoric acid fuel cell. Pure hydrogen or hydrogen rich gas is supplied at the negative electrode, and oxygen or typically air is supplied at the positive electrode. So it is for all fuel cells, this is very common. The fuel is supplied at the negative electrode, and the air is supplied at the positive electrode. The pores here provide an opportunity for the gas, electrolyte, electrode to come in contact for the electrochemical reaction. So essentially hydrogen, oxygen and the phosphoric acid combines to form an electrochemical reaction, and this electrochemical reaction also liberates electrons, so which is collected in the form of a current, and then the byproducts, which are usually water, is taken out. And this reaction is very slow, and a catalyst is required in order to accelerate the reaction, and this catalyst is used at the electrode side. The typical catalyst used in the phosphoric acid fuel cell is either platinum or nickel in case it is used at the negative electrode, or sometimes there is an attempt made to use silver as a catalyst at the positive electrode. So the reactions which take place at the negative electrode, the hydrogen is split into hydrogen ions and electrons, and at the positive electrode the oxygen atom is split into the oxygen, which is combining with the hydrogen is combined basically into the water, And the overall equation therefore becomes that the hydrogen and oxygen combines to give out the electricity, water and water vapor and the electricity as well. So a video which shows the explanation of the working of this.
Okay, let's begin the reaction that takes place in the phosphoric acid fuel cell. First, hydrogen from the fuel cell is extracted using an external reformer. The excess fuel is reused to produce more hydrogen.
Then the hydrogen travels to the anode.
The anode is made of porous carbon, which also contains small amounts of platinum. The platinum acts as a catalyst that causes the hydrogen atoms to split into H+ ions and electrons. The electrons will begin to move towards an external circuit, while the hydrogen ions will move through the electrolyte towards the cathode.
When the electrons pass through the circuit, it produces the energy needed to power the RV. The electrons and positively charged hydrogen ions, along with the oxygen atoms, then unite in the cathode to produce.
So that is how this phosphoric acid fuel cell operates. Another video which shows a similar working.
Fuji Electric Systems exhibited a mock-up that simulates the structure of a phosphoric acid fuel cell for commercial use, with a power generation output of 100 kilowatt at the FC Expo 2009 show. The company also introduced the characteristics and performance aspects of this fuel cell. The main characteristic of the phosphoric acid fuel cell is the impregnation of a phosphoric acid aqueous solution as the electrolyte in the matrix.
こちらの方はリン酸型燃料電池といいまして、世界の中で唯一商品機として世の中に出ているものでございます。で我々の機種は100キロワットの機種で、おおよそですけれども100件分ぐらいの一般住宅の電気を賄えるというものでございます。で今日こちらの会場に持ってきているものは実物大のモックアップで、実物そのものではなくて写真貼ってますけれども、中身の構造とかが分かるような形でご紹介しております。
Fuel cells generate electricity through an electrochemical reaction between hydrogen and oxygen with the help of an electrolyte. There are several types of fuel cells that use different methods for generation. For this phosphoric acid fuel cell, Fuji Electric Systems developed high-precision control technology that ensures steady reaction in the three phases of solid, liquid, and gas. Namely, the solid electrode, the liquid phosphoric acid electrolyte that creates the ion path, and the hydrogen and oxygen gases. With this technology, the company has already achieved an operational lifespan of over 40,000 hours with the commercial fuel cell.
100キロワットのリン酸型燃料電池は一般住宅向けではなくて業務ビルとかですね、ホテルとか病院とかそういうところの熱を使うところのコージェネレーションとして広く使われております。でそれ以外にも下水道からの汚泥から出てくる消火ガスとか食品残渣物から出てくるようなバイオガス、それから工場から出てくるような複製水素も利用可能で高い発電効率で運転できるという発電装置でございます。
The 100 kilowatt phosphoric acid fuel cell has a high power generation efficiency of 42%, outputs minimal noise and vibration, and is a clean source of power generation that is environmentally friendly. With the use of this PAFC fuel cell, significant reductions in carbon dioxide can be expected. Digging for news.
So this was way back in 2009. So the research has started at a very early stage, and this clipping was basically from an expo that the company used to showcase their product. The next type of fuel cell is an alkaline fuel cell. It is the oldest of fuel cells that are used. It basically uses aqueous potassium hydroxide as an electrolyte, and the operating temperature is about 90 degrees Celsius. The electrodes and the other details are very similar to the phosphoric acid fuel cell except for the change in electrolyte. The next type of fuel cell is a molten carbonate fuel cell. The physical appearance of this cell looks something like this. So what happens here is a carbonate of alkali metals, usually sodium, potassium or lithium, in the liquid phase or in the molten phase is usually used as an electrolyte here, and the cell operation is at a very high temperature, usually in the order of 600 to 700 degrees Celsius. Because there is a high temperature of operation, catalyst is usually not used, and the porous nickel is used for the electrodes, and the electrolyte is held in a sponge like a ceramic matrix. So there is a matrix formation which is spongy in nature, and porous nickel is used at the electrodes, and the electrolyte is held in this matrix, sponge matrix. The special feature of this kind of a molten carbonate fuel cell is that during operation they oxidize hydrogen to water and carbon monoxide, which is present in the fuel, to carbon dioxide. Hence, the output is a gaseous mixture of both hydrogen and carbon monoxide, usually known as synthesis gas, which is relatively inexpensive to manufacture, can also be used. So the byproduct here, the synthesis gas, can also be used for particular applications. The fuels are first converted to get the hydrogen, carbon monoxide, and then desulfurized to prevent any damage or poisoning of the electrodes here. The theoretical value of EMF that is produced is 1 volt at a typical operation of about 700 degrees Celsius. The discharge usually consists of steam, some amount of steam, and then carbon dioxide and nitrogen. And these hot gases could be used to provide heat or to generate additional power. That is, the synthesis gas is what it is being talked about here. Thus, the overall efficiency of the fuel can be increased substantially. So, nothing goes as a waste here, and it is effectively utilized. The next type of a fuel cell is a solid polymer fuel cell. So here a solid membrane of the organic material, usually some acid is used that allows the hydrogen ions to pass through it, which is used as an electrolyte. A thin layer of membrane is used to keep the resistance. So the membrane here is kept as thin as possible. So this is done to reduce the internal resistance. And then what also happens here is there is finely divided platinum which is developed or deposited on the surface of the membrane, which acts as a catalyst. So the catalyst here is platinum, and it also ensures that the electrons or the current is collected and delivered at the output. So in operation, the hydrogen enters a closed compartment and interacts with the negative electrode and gets converted to hydrogen ions and equal number of electrons. So a video on how this works.
How do you do, everyone? My name's Platinum. That's what the PT means. I do a lot of work in fuel cells as what people call a catalyst. That means I help other elements to react together. Nothing happens to me, but the other elements react faster when I'm there. These fuel cells generate electricity. To do that, they use hydrogen and oxygen. Let's take a look inside. A fuel cell has chambers for hydrogen, for oxygen, and carbon powder between them. On the grains of carbon are lots of very tiny nanoparticles of platinum.
Hi.
How's it going?
How are you?
This is the hydrogen chamber. Here it comes! Huh! I split electrons off from the hydrogen. The electrons flow out in a current, and that's electricity. This is the oxygen chamber. Here come the positive hydrogen ions. And their electrons. And here's oxygen. I shake the oxygen atoms and split them in two. Take an oxygen, two hydrogens, and the electrons. And look! We've got H2O! Plain old water. After a fuel cell makes electricity, all that comes out is water. Clean, environmentally friendly energy. And it's all because of me.
So the platinum here is essentially doing all the required job. The next type of fuel cell is a solid oxide fuel cell. Here a certain solid oxides, usually ceramics, at high temperature can be used as an electrolyte. Example, some applications use zirconium oxide, and the material is able to conduct the oxygen ions at a very high temperature. The negative electrode is made of porous nickel and the positive electrode employs a metal oxide. The operating temperatures is in the order of about 600 to 1000 degrees Celsius. Due to the high temperature operation, a catalyst is not needed. So wherever the fuel cell operates at a very high temperature, a catalyst is not usually employed. So this was about a brief working of the fuel cells. We now move on to understand the other forms of green energy. Next set of topic is the magnetohydrodynamic power generation, or MHD power generation. It is a new system of electric power generation which is considered to be very highly efficient and low on pollution. So this method of power generation deals with the flow of conducting fluid. There is a fluid which flows, and this fluid is very conducting in nature, and this fluid is made to flow in the presence of a magnetic and electric field. This fluid could be usually either gas, which is at elevated temperature, or liquid metal, like for example sodium or potassium. So the device which converts this power is called a MHD generator. So what this does is this converts the energy of a fuel directly into electrical energy without a conventional electrical generator. So this is hence a new system of electric power generation. MHD is basically based on the Faraday's law of electromagnetic induction, and it provides DC power directly at its output. So what happens here is the gas or the fluid is passed at a high velocity through a full complete magnetic field. So this magnetic field, a current is generated due to this, and it can be extracted by placing electrodes in a suitable position along the stream of the flow of fluid. So an EMF is induced in the direction of right angles as per the Faraday's law. The MSG systems are broadly classified as open cycle and closed cycle, with the closed cycle being subclassified as seeded inert gas and liquid metal system. In the open cycle system, what happens is there is a combustor system. This is a complete setup of a regular conventional steam power plant, wherein the MSG system is added here. The fuel or the hot air, when the fuel and the hot air, when it combusts and is coming out, is made to pass through a nozzle and is then made to pass through this MSG system. So this MSG system conducts the air, which is the working fluid here, and then tries and generates power through the use of an inverter and generates AC power. The inverter converts the DC power into the AC power, and this hot gases then is made to pass to the air preheater steam generator, and the, as I said, the regular system works. So the seed recovery is to ensure that the particles that are needed for the magnetohydrodynamic system are reused, and additional agents are added as a makeup kit, and this is sent. In a closed cycle, it is as the name suggests, the MSG system is working fluid is reused. Typically there is argon which is taken as the working fluid, and it is the conventional steam system that is being utilized. So the steam gives the heat to the secondary heat exchanger, which has an MSG generator attached to it. So this heat, the air from this combustor is made to pass through the MSG generator. Then the exchange of heat takes place. So this exchange of heat, the working fluid in the secondary cycle absorbs the heat, and this is then made to run a conventional steam turbine. The argon which is used is then compressed and sent back into the primary heat exchanger, and this is this MSG system is connected to an inverter which generates the required power. Although this is only a theoretical concept, attempts have been made to conduct experiments and obtain the values. However, it has been not commercially successful so far. The next method of green energy is the thermoelectric power conversion. It is the power conversion or power generation mechanism through the Seebeck effect. So this method makes use of the Seebeck effect. The efficiency depends on the temperature that is obtained at the hot and cold junction in any heat engine. However, again, just like the MSG system, this efficiency is very low, in the order of 1:3%. There is a video which demonstrates how this could be used to generate power.
To first introduce the concept of power generation, we have this simple demonstration set up. Heat is applied to one side of this thermoelectric device. It causes electrons to flow in the completed circuit here, resulting in enough power to energize the light emitting diode. The phenomenon of power generation is made possible by creating a temperature difference across two surfaces of the thermoelectric device. Much like in electrical generation, it results from the movement of a magnetic field across the conductor. It's the movement of the heat across the semiconductors that causes the electrons to move. Just as when the magnetic field ceases to move, electron flow stops. When the heat ceases to move, the electron flow stops.
So that was how the thermoelectric power conversion works. The next is nuclear energy. We all have been introduced previously to the nuclear energy. Predominantly, there are two methods of energy production, the fission and the fusion method. There is a video which demonstrates, which gives you a quick overview of how both of these work in extracting the energy. So that was a nutshell of how the nuclear energy works. The next method of green energy is the ocean thermal energy conversion, or in short OTEC. This is basically utilized in the form of temperature difference between the surface water, which is at a little higher temperature, and the deep water, which is at the lower temperature. So this temperature difference could be utilized to generate power in a conventional turbine. The OTEC plants could be classified as open cycle, or more commonly known as Claude cycle, and closed cycle, also known as the Anderson cycle. In the open cycle, as the name suggests, the water is discharged into the system, and the fresh water is used for each cycle of power generation. The warm seawater is made to pass through an evaporator where it flashes the vapor. This water vapor contains heat. This heat is utilized to run a turbine and a generator, and thus the power is produced. Once the power is generated, the distillate, the condensate that is coming out of this turbine is made to pass through a condenser where the wet steam is completely converted into the water and then left into the downstream. So it gets mixed with the seawater at the bottom. In a closed cycle, the working fluid is reused again and again. So here the warm seawater is pumped into the evaporator where the temperature increase occurs, the steam gets flashed, the water flashes itself, and the turbine, in the evaporator, the steam is generated. The steam is made to pass through a turbine, and then the power is produced, and then the condensate is made to pass through a condenser, where the wet steam is completely converted into the water, and then this water is taken back into the evaporator again. And additionally, at certain periods of time, the warm seawater is also added into the evaporator, so that this cold water and then this warm surface water combines in the evaporator, and then the cycle operates. The next form of green energy is the geothermal energy, which is the energy present in the form of heat in the Earth's crust. So this energy could be utilized to generate power at zero emissions, and hence is one of the alternative. However, it is very limited to certain sites only. This is not found very widely and is limited to certain areas in the map. And also it is to be noted that most of these geothermal sources produce low grade heat at in the range of 50 to 70 degrees Celsius, which can be used for direct thermal applications. There are various forms of geothermal system: the hydrothermal system, then the high temperature system, low temperature system, then the hot water field, geopressed, petrothermal or hot dry rocks, the magma sources, volcanoes, etc. There is a video here which shows the utilization of geothermal energy in a brief nutshell.
Geothermal energy is the heat energy acquired by the earth. Here, the source of the heat is earth, hence the name is geothermal. Heat inside the earth is available at a depth of more than 80 kilometers. In some locations, it is available at a depth from 300 to 3000 meters. Such locations are referred to as geothermal fields. Geothermal energy is used for heating water, air conditioning, electricity generation, greenhouse heating, etc. History of geothermal power plant. The world's first geothermal power plant was built in the year 1911 in Larderello in Italy. Working principle of a geothermal power plant. There are three types of geothermal power plants. Let us study the working of each. First is the dry steam power plant. In this power plant, steam is generated directly from the geothermal reservoir. This steam is directly supplied to the turbine, which is coupled with a generator. The flow of steam causes the turbine to rotate, and because of this, the generator produces electric energy. After rotating the turbine, steam goes through the condenser where it is converted into water. This water is called as condensate, and it is injected back into the earth through the injection well. Natural dry steam hydrothermal reservoirs are very rare. The next type is the flash steam power plant. This type is used where there is an availability of geothermally heated water at a high temperature of over 350 Fahrenheit. This water is called as brine, and it is transferred to a vessel where steam is generated. This steam drives the turbine coupled with the generator to produce electricity. The waste brine is injected back into the earth. Last is binary cycle power plant. This is used when the geothermal resource is at lower temperature of up to 100 Fahrenheit. Here, the hot water is passed to a heat exchanger which is combined with the secondary liquid with a lower boiling point such as butane and pentane hydrocarbon. A mixture vapor is generated and it runs the turbine. The mixture vapor is cooled by condenser and the liquid is recycled. Wastewater is injected back to the earth. As this power plant requires two liquids, water and secondary liquid, it is called a binary cycle power plant.
So that was about the use of geothermal energy. The next is the concept of zero energy. This is something where there is no energy utilization involved, and this involves typically the design of buildings and then utilization of energy in such a manner that ultimately there is no electricity bill generated.
What is a zero energy building? Most buildings today use a lot of energy to keep the lights on, cool the air, heat water, and power personal devices. Even installing solar systems will not significantly counter the heavy energy load. There are, however, some buildings that strike a balance, or even tip the scales the other way. These are called zero energy buildings. They manage this feat by being extremely energy efficient, saving 50 to 70% more energy than typical buildings. In these ultra-high performance buildings, the amount of energy used can be completely offset by renewable energy produced on or around the building. When conditions are not suitable for energy generation, the building will draw energy from the electrical grid to meet its needs. When conditions improve, the on-site renewable energy systems will cover the building's energy need and send excess energy back into the grid to make up the balance. Over the course of a year, the building gives back as much energy as it takes. When zero energy concepts are applied to groups of buildings, the benefits are shared and multiplied within that zero energy community. These buildings are also more comfortable, more reliable, affordable to build and operate, and better for the environment. While these might seem like buildings of the future, new technologies are constantly emerging that make zero energy easier and easier to achieve today. In fact, there are already hundreds of zero energy buildings across the US and many different climates. By becoming ultra efficient and giving back as much energy as they consume, zero energy buildings will play an important part in creating a more competitive, energy secure future.
So this was about the concept of zero energy. If you haven't considered subscribing my channel, please consider subscribing, and please hit the bell button so that you can get further updates and you can enrich your knowledge.